Hey everyone, welcome to DevProdEng Showdown. Thanks for joining today. A very exciting show for you all today, focused on Android architecture. Here's how everything is going to work. We have four panelists. We're trying to get to 7 to 8 topics, somewhere around there, and get you to your next meeting right at 30 minutes after. Um, each participant panelist gets 30 seconds per topic, and then you, the audience, votes on whose answer you like best, right? Who did you learn something new from around productivity engineering? That's our main motivation for doing this, to bring these topics of engineering at scale and productivity engineering to the world and the community. And so thanks for participating. Let's jump into it. Wanted to introduce the panelists for today. We have Angela from Dropbox. She's been working in Android for 8+ years. The app kind of grow to how large it is today. We have old pal of mine, Cesar at Twitter. He's been at Twitter and Android for forever. To the topics. First topic for today, Android architecture components. Yes or no? Angela, you're first.
Um, yeah, so this is a large topic. So, yes or no, I would say both. I tend to be pretty cautious to adopt anything that's going to cause a dependency ripple throughout the code base. If anyone thought that RxJava was always going to be there and be our standard, has experienced this pain. We made that choice. We have RxJava everywhere in the code base right now, and we're converting over to coroutines. Specifically, though, there are some aspects of Android components that I really like, and those are ones that are overly complex.
Oh, sorry, we had to cut you off there. Cesar, what do you think?
I think they're great in spirit, and I think that they did a great service to the community by promoting strong design practices. We did find them to be a bit too coarse for our needs for granular reuse at scale. And we have the abstractions for serving a similar purpose that the decoupler features for Android and allow for injection. Now, what I'd love to see in future releases is that they take on breaking down the Android context into atomic objects for injection and providing the standard fakes that we can use for tests.
All right. Jake, what do you think?
Yeah, I am generally opposed to these. The architecture is built on the foundation of fragments, which inflict and infect its poor API design and layering violations through the rest of your app. Any benefits therein are offset by this like myriad of glue that you have to introduce to work around its faults. I think the biggest condemnation of this is that internally Google has to have an entire team for its first-party apps abstract away architecture components because they don't trust developers to use them.
Tell us what you really think, huh? No. Michael, why don't you wrap it up?
All right, I'm going to go with yes, but like anything in software, it depends. It's a great starting place if you don't already have an architecture, but as you scale, you're going to want to swap that out for something that works better for you. You do want to build things lifecycle aware, so that part's good. You're definitely going to want to use things like Work Manager and App Startup. Those parts are great. Other things like data binding are less relevant with things like Compose. If you are using any of the architecture components, be sure to use the KTX extensions.
Nice one. Awesome. Audience, now time for you to vote on who you think gave the best answer and the best argument. All right, Michael. Nice. And you gave some great answers there. It was close. It was close. Jake was right there on there, but you went deep into what's really inside. Amazing. Okay, let's go to the next topic. Modularization, right? This is a hot topic in Android development, right? How many modules is too many modules? Where do you draw the line? And can a module be too small, right? Okay, Michael, you're up first. What do you think?
I think more modules are generally better in a well thought out module structure. It helps you parallelize your build, promotes reusability and encapsulation, especially with Gradle config cache. The performance penalty is going to be smaller with more modules. Of course, it's a balance. If you put one function in every module, that's too small of modules. So you have to think about it and make a plan for how you're going to divide it up into modules.
Okay, great. Jake, what do you think?
Yeah, I think the most important thing is enabling feature teams to be able to work without stepping on each other's toes. So having top level folders for each feature. And then within that, sort of having a micro app with proper layering so that if someone is working in the feature, they're only working in their folder. But people working cross-cutting across the code base maybe have to step in at like the data layer or view layer, only have to touch sort of a single module in each feature rather than sort of a giant goop of interconnected mess that you otherwise would see with sort of more monolithic modules.
All right. Cesar.
I don't think there's such thing as too many modules, and I don't think that any module is too small, with API modules, for example, being typically tiny. That being said, managing a large number of modules can be extremely costly, so we need to be very thoughtful on how you go about it. So you may want your modules to offer a single responsibility or have API and implementation modules in order to hide portions of the code base. The standard code is structured in layers to facilitate navigation, and then a build pipeline with minimal overhead that supports build.
All right. Angela, you want to wrap it up?
Yeah, echo what everyone else said. I don't think there's too many modules, and I don't think you can have them too small. But one of the challenges I see is when you do have a lot of modules is that discoverability piece and ensuring that in order for someone to utilize your functionality, they don't have to add dependencies for 4 different modules, for example. If that's the case, let's think about high cohesion and low coupling in our modules just as we would in our classes. We actually experienced this at Dropbox as we are trying to go towards clean architecture, so we can talk about that more another time.
Yeah, no, that's great. I mean, dependency management pressure. I was wondering who was going to bring that up. Audience, let's see what you think. Who made the best point? All right, Angela, we got you on the board. All right, one of our favorite topics here. If you can ask the Android Gradle plugin team for one single feature or bug fix, what would it be? Jake, you're up.
Yeah, so for me, it's single variant library modules. Everyone likes to complain about things like lint being extremely slow. In AGP3, every library module gained a second variant, which caused every task in that library to be duplicated. And so there's now this doubling of work that's spread across your entire CI build. It's not a huge problem if you have 4 modules. It starts to become a problem if you have 40. Well, once you reach into the hundreds, like 400s, you're wasting just a ton of time building the same code twice in every library.
Nice. Very good. Good one. Cesar, what do you think?
I'd love for ADP to support the publication of test utilities with every library so that depending on a library, it would automatically make those test utilities available to your tests. Kotlin extension functions should make them super easy to discover. And I think that it matters a lot because it allows libraries to document how to test them. And it also encourages them to be testable by design, which I think should be way more important than we make it.
Nice one. All right. Angela, you're up next.
Yeah, I actually went to our platform team to ask them about this question because I'm pretty far removed from this portion. And they were just complaining about performance from the Android plugin. So we have a big legacy code base. We're starting to break it up in different modules. And now we have all these Android plugins running. And it takes anywhere from hundreds of milliseconds to a second just to run the configuration phase. And they're like, please just make that faster. Or cacheable, even better.
All right. And Michael to wrap it up.
Yeah, if I had to pick a single thing, it's going to be shorter release cycles with a new stable release every 2 months. Even if there's not much in that release, just get those stable releases out there. Since I have a few more seconds, you know, a well-documented stable API would be great. And of course, faster builds.
Yeah, everybody's asking for the faster builds. Okay, audience, let's have you vote here on who gave the best answer. Which you're voting for the 8GP feature. I'm kidding. It's we can't. It's not us on that. So, but. All right, Jake, you're on the board. All right, let's get to the next topic here. What's your stance on mocks and fakes? Does it change depending on the scope of the test, unit versus integration? Do you run integration tests against real backend? Cesar, you're up first. What do you think?
We run minimal live tests just because they are extremely hard to maintain across repo and team boundaries. So we're focusing on validating contracts against fakes. Mocks put the burden on tests to replicate the contracts, which make them really brittle. Yeah, not a huge fan. Fakes, on the other hand, are guaranteed to implement the right contracts, and I think are the right way to go, particularly provided by libraries.
All right. Next one. Next up, Angela, what do you think? Mocks and fakes.
Actually use a mix of both. There are pros and cons, especially if you're using something like Mockito Kotlin, just to simply throw up a quick black box unit test. But in general, I'm thinking about how to reduce complexity in my test. I think less about whether or not it's mocks or fakes and how do I ensure this test is easy to understand its APIs, easy to understand how you set it up, what you're testing, and that you're not getting into the implementation details too much. Definitely seen fakes go down the path before.
Okay, great. Right in time. Michael, you're up next.
I would advise to avoid mocks whenever possible. Any gains that you get from mocks being easy to write tests will be lost when somebody has to debug them or deal with them later. With Kotlin, fakes are easier to write, and they're easy to step through with a debugger. Also, you want to assert on the state of your fake or your system instead of verifying that certain functions were called. If you're for real backends or not, I suggest using scripted server responses and not real backends.
Okay. And Jake, to wrap it up.
Yeah, I'd like to ask whether or not mocks or fakes are even appropriate. The first question you should ask is whether you can use a real implementation. When you're substituting a list from a class that's test, you don't mock the list, you don't fake the list, you give it a real array list. There's really no reason for a large portion of cases that you can't use a real in-memory database or your real business logic. And you could argue those are more integration style tests, but it means you sidestep the whole problem of whether your mocks or fakes are correct. But if it is mocks or fakes, never, never, never mocks.
This was a good one. Very interested to see what the audience has to say here. You guys all gave great answers. All right, audience, let's kick off this poll. All right, Jake. See, you didn't even need those shadow accounts. You were good. You're on the. Jake's in the lead.
Clearly not fake.
Yes. All right. What's your stance on legacy code, right? What's the balance of updating it versus building new functionality? This whole technical debt topic is super interesting. Um, uh, Angela, you're up next. What do you think?
Okay. This is something I think about a lot working on an old code base. In general, I look at always moving forward. And so I prefer to be working on new functionality. And so the only time I touch legacy code is if it's causing us problems. So it's causing us production outages, it's causing us to slow down on our functionality, dependency site or development cycles. That's when I start looking at legacy code to say, how do we better encapsulate this? How do we make sure it's stable? If it's already encapsulated, it's already stable, leave it be.
All right. Okay. Cesar, what do you think?
I think that legacy code is a reality. You would handle it only as it gets in the way of building new features. A full rewrite is rarely a possibility. It's just way too easy to introduce subtool bugs. But we've been very successful at doing incremental rewrites, particularly we planned them very carefully. And we were able, for example, to replace every single list view in the application with a recycler view, rewrite the whole tweet view, composer. This is extremely critical functionality that we rely on, that we were able to rewrite just through careful work.
Nice. Jake, you're up next.
Yeah, obviously there's a balance that needs to be found here. And I think the choice of the libraries and tools you use to build your architecture can either help or hurt you. Choosing ones that I will not explicitly name may result in you leaking that legacy code debt into more of your app where it's harder to refactor. Whereas things like strong encapsulation of your features and then strong encapsulation of even layering through your app means that things that are legacy don't have that much of a blast radius on the rest of your app, such that you can carry them for longer.
All right. Michael, wrap it up.
Yeah, you have to do chores on your old code. You have to update the dependencies and kind of do a little bit of gardening there. But other than that, if it's not broke, don't fix it. In any sufficiently large app, some old style code is inevitable. Gradle modules can help you separate the old style from the new. But the time to modernize is when you're working on the code for other reasons, to meet product requirements or to add new features. That's the time to modernize it and bring it up to your latest standards.
All right, great. All great answers. All right, let's see. Audience, what do you think? Let's kick off this poll here. Hey, got Michael on the board, tying it up with Jake. All right. Another favorite topic of ours, how do we architect apps for evolving functionality, especially when 20 plus engineers work on the same code base? This is a problem all of you have dealt with in the past, just those apps at scale, right? What do you guys think? We're starting with Michael on this one.
Yeah, I'd summarize my answer as kind of communication and automation. A good Gradle modularization setup is very important. Solid CI with the right amount of tests. Don't merge code that has failing tests. Make sure you're paying attention to compiler warnings, static analysis issues. And then you want good documentation for the current patterns that you expect developers to use, patterns, practices, guidelines, and the architecture as it evolved. Make sure it's documented and they know what's expected of them when they're making changes to the system.
Okay, great. Jake, you're up next.
Yeah, I mostly have the same answer to this question as I had to the last one. The ability to handle legacy code in your code base is also the ability to take parts of your code base and evolve them rapidly due to changing product needs. The ability to completely rewrite a feature, to add a new feature, to change how your navigation works, to swap technologies that are driving the data layer, the presentation layer, or the view layer of your app. All this comes down to just having good feature separation and then good layering separation in your modules.
All right. Cesar, what do you think?
I think that, you would use the typical practices, encapsulation, collocation of your code, insulation and decoupling, a bit like Jake and Michael described. I think it's especially important that you design for the developer experience and that you invest heavily in tooling and usability. So we're using ideas like this to build sandboxes that have developers work on their tiny spaces that take like 20 or 30 seconds to build.
Okay, great. And Angela, to wrap it up.
Yeah, some of the ways that like everyone's talked about already is encapsulation. I think it's also really critical to have a clear architecture paradigm throughout the code base and ensure you have strong unidirectional data flow and are using immutable data. One of the challenges when you have huge code bases is even if you have good encapsulation, if the data can change in odd and unexpected ways, then all of a sudden debugging and understanding production outages becomes this multi-day stressful experience of pulling in all these different teams. If you have clear contracts, you're good to go.
All right, great. All right, audience, what do you all think? Let's kick off this poll. All right, Cesar is on the board. Close one with Michael. Michael also gave a great answer. Everybody gave great answers there. All right, we are in the lightning round because we're trying to fit in 2 more topics before we get everybody to their next meeting. So everyone gets 15 seconds each on this one. So yeah, let's jump into this next one. How do you balance feature development with test coverage, right? This is one of the very hot topic here at our company, Gradle here. Let's kick this off with Jake. What do you think?
Yeah, test coverage is a lot like brushing your teeth, where you kind of just know the right amount to do. Someone could tell you like you got to do 2 minutes, you got to floss every night, but then you're going to wind up like resenting them for it. And ultimately, the failure to do this is on the team itself when problems happen in production. So you're your own worst enemy.
Okay, I love the brushing your teeth example. Cesar, what do you think?
I think that test coverage is critical in stable features, maybe not so much when prototyping, but it requires the right incentives. So you want to make sure that all your systems are testable in the framework, that you establish the right standard practices, that you have no flakiness, and you have super fast test execution.
All right, lightning round, yeah. All right, here we go. Angela, what do you think?
Yeah, I focus in on test coverage around the complex areas and the most business critical areas. If I have to balance feature development against testing, if I can throw in a couple of smoke tests, full acceptance tests that hit the key user workflows, I do so, but really just want to make sure it's stable.
Okay, great. And Michael, to wrap it up.
All pull requests must have tests that cover the changes that are being introduced. Tests are not optional, they're expected. You have enough test coverage when the number of bugs being merged into your main branch is sufficiently low.
All right, great. With a few seconds to spare. All right, audience, let's kick off this poll. Whose answer did you like the most? Michael won. Nice, awesome. All right, good one, Michael. All right, we got one more topic. Yeah. All right, question number 8. Methodologies for building UI, MVI, MVP, Does it matter anymore with Jetpack Compose? Let's go with Angela.
Yeah, I've actually never been overly concerned about which methodology we use as long as it's testable. We have unidirectional data flow and we're using immutable data objects. So therefore, just use Compose at this point. I think that's the way to go.
Okay, great. Let's go with Cesar. What do you think?
I'd go with MVI for the immutable state and composability. It makes it super easy to reason about your UI. And I think it fits very well in the declarative UI model that Jetpack Compose is proposing.
Okay. And let's go with Jake.
Yeah, picking one of these is essential for things like testability, and Compose tends to flirt with the practice of having business logic mixed in with presentation logic, such that we still need to have one of these and maintain very strict separations, primarily for testability.
Okay, I like it. And Michael, to wrap it up.
The important thing is that you have an architecture, make sure it's documented, make sure everybody is actually using it. Of course, you want unidirectional data flow. You want your UI to be purely a function of your immutable state. But Compose is the future. So Compose with MV whatever is the future.
Okay, love it. All right, audience. Let's kick off this poll. Michael's just killing it today, right? Amazing, amazing. So Michael, you well, thanks for everyone for participating. Michael, you get your 15 seconds of fame to as our winner to talk about whatever you want to talk about.
Yeah, come work with us at Amex. I've got great colleagues to work with, lots to learn. Unit testing is something we really focus on. We take care of our people. So yeah, Amex is hiring.
Okay, amazing. Well, thanks everyone for joining today, and thank you to our panelists. You all are amazing, and it was a great one, and we get you right in time to even have a bathroom break before your 10:30 a.m. So thank you, and thanks. Jake Scott, you still have that from Google I/O? What was that, 2018?